In this lecture, we are going to discuss about what is stress, what is strain, and what are the different types of stresses and strain. So, finally, what is the relation between stress and strain? Okay, so this is an important class for your strength of materials, because for the remaining 5 units you are going to use the terms stress and strains frequently. Okay, so uh, understand the concept of stress and strains very carefully. So we'll start with what is stress. So stress is a measure of internal resistance exhibited by a body or a material when an external force is applied to it. So for example, this is our object, okay, and I am applying a force F in each side. Okay, so when the force is applied, then an internal resistance will be exhibited in the body. Okay, so this internal resistance offered by the body oppositing to the force is called as stress. Okay, so whenever if you apply a force on a body, then the body will try to resist the externally applied load. Okay, so that internal resistance is called as stress. So you can see the image. So here it's a rectangular rod, and a force of F is acting on it. So the cross section of the rod is A, that is area. So when the load is applied, you can see that an opposite resistance is produced inside the body. Okay, so that is an internal resistance offered by the body that will resist the motion. Okay, so that is called as a stress. Okay, and the equation for stress is equal to load by area. Load means it is applied load divided by the cross sectional area. So in this image, the applied load is F and the cross sectional area is A. So we know that for circular cross section, the area is pi by 4 d square, or it is pi r square, and for rectangular cross section we know that the area is p into h. Okay, so similarly you can calculate the area, the applied load will be given, and we can calculate the stress. Okay, so the unit for stress is, if you substitute force in Newton and area in mm square, then the unit is Newton per mm square. If you substitute force in Newton and area in meter square, then the unit for stress will be Newton per meter square. Okay, so be clear about it. The units are very important. Okay, so always try to use mm. Okay, don't use meter. Always try to use mm. Okay, so stress means it is the internal resistance offered by the body. The next one is, before that, it's application of stress. So you can see that the rope is carrying a light and it is fixed on the ceiling. Okay, so here the light is having a weight of P. Okay, so according to the mechanics of rigid body, that is your engineering mechanics, this rope will not undergo any deformation, because that is considered as a rigid body in your engineering mechanics. But in actual case, it is actually a deformable body and it is subjected to some amount of deformation. Okay, so according to strength of materials, this rope will undergo some deformation, which means this, you can see that this is the cross section of the rope. Okay, so when the load is applied, this rope will feel some internal stress in it. Okay, so that stress you can calculate by using this equation, that is sigma is equal to P divided by A. So here the area is, since it is circular cross section, it is pi r square or pi by 4 d square. Okay, so this is how we have to calculate the stress, and the unit is Newton per mm square if you substitute r in mm. The next one is strain. Okay, so when the body is subjected to some external force, there is some change in its dimensions. So the ratio of change in dimensions to the original dimensions is called as strain. So here you can see that here a circular rod is subjected to a force of F. So when the load is applied continuously, then it will undergo some deformation. So it will change its length like this. It will undergo some deformation. So this change in dimensions, you can see that. So this is the change in dimension, dl. So this ratio between the change in dimensions to the original dimension is called as strain. So whenever in each and every object, when you apply some load, then the system will undergo some change in dimension. So if you pull elastic, then it will undergo some deformation. Okay. So strain means it is the change in dimensions to the original dimension. So if we are focusing on length, then it is change in length divided by original length. If you are focusing on the diameter, then it is change in diameter divided by the original diameter. Okay. So the change in length here, the initial length is L. So this is the original length, it is L, and the change in length is dl. So the equation for strain is strain E is equal to dl divided by L, that is the change in length divided by original length. Okay. So when the force is applied on a material, then the material will feel some internal stress, and because of that internal stress, a strain is produced. Okay. So the stress will apply an internal resistance. So when the force exceeds the internal resistance, then the strain will be produced. Okay. So the equation for strain is change in length divided by original length. Okay. So here the strain has no unit because the change in length will be in mm and the original length will be also in mm. So there is no unit for strain. Remember that there is no unit for strain. So you can see the animation here. So when the load is applied, then it changes its length. Okay, so this is called as strain. Then the types of stresses. So we'll start from axial stress, that is tensile stress. So when the stress induced in a body when subjected to two equal and opposite pull forces. So when the body is subjected to two pull forces, then it is called as tensile stress, and the strain produced by this tensile load is called as tensile strain. So we know that the equation for stress sigma is equal to force by area. So here the force is acting outward in the outward direction, so it will change its length, and some internal stress is developed, that is sigma is equal to F by A, that is Newton per mm square. Okay. So because of the tensile load, the tensile stress is produced. Okay. And the strain associated with this type of stress is called as tensile strain. Then the next one is compressive stress. So here the body is subjected to two equal and opposite push forces. Okay. So here you can see that it is subjected to push force. So in tensile, the length will be increased. In compressive, the length will be decreased. So this is your object after some time, after the load is applied. Okay. So this is a compressive load. So here the force is acting towards the object. So this is the compressive stress. So here it is an example for compressive stress. So it is actually a vertical column, your pillar. So because of the compressive stress, the material is broken. So here the force will act like this because of load, weight, and your vehicle weights in the bridges. The load will be applied like this. So it feels some compressive stress. So here also the equation for compressive stress is again same. It is P by R, force by area. So here the force is acting as a push force, and the unit is Newton per mm square. So this is the second type of stress. The third type of stress is shear stress. So the stress induced in a body when subjected to two equal and opposite forces which are acting tangentially across the resisting section. So here you can see that. So this is actually a bolt or a rivet. So two plates are connected by using the rivet, and in one plate the load is acting towards left side, and in other plate the load is acting towards right side. Okay, so this kind of stress is this kind of load will produce some shear stress. So when the load is applied, you can see that there will be a crack in this location, or the material will break at this location. So this is called as shear stress or direct shear stress. So here the two forces are acting tangentially across the resisting section. So here this is the resisting section. So you can imagine I am going to cut a chalk piece, or I am going to cut a paper with the help of a scissor. So the scissor is operated by using the principle of shear stress. So in scissor you can see that, so one part will move in the downward direction and one part will move in the opposite direction. So when these two meets, then the paper will be cutted. Okay, so here the shear stress is applied on the paper. So two relative opposite forces are applied on the paper. So this kind of stress is called as shear stress, and here the equation is sigma is equal to P by A. Here the A is this area resisting the stress, area resisting the force. Okay, so this is the shear stress, and here also the unit is Newton per mm square. Okay, the next, so these are all the different kind of stresses. The next, before going to see the relation between stress and strain, we must know about elasticity and plasticity. So what is elasticity? Elasticity means, you should remember, an elastic. So I am going to apply a load on a material, and once the load is removed, then the material will come to its original shape. Okay, so that is called as elastic material. So elasticity is the property of a material to regain its original shape after the deformation when external loads are removed. You can see that. So here I am applying a load. So the material deforms. When the load is removed, then the material will come to its original shape. So this is called as elasticity. So just remember your elastic. When you apply load, then it will deform. So once if you remove the load, then it will come to its original shape. So that is called as elasticity. The opposite one is called as plasticity. So remember plastic. So here permanent deformation is produced. So when the load is removed, the material will not come to its original shape. You can remember, you can see steel. So the steel is bended, and once the load is removed, the steel will not come to its original shape. So this is called as plasticity. So elasticity and plasticity are opposite. Okay, so elasticity means just remember elastic. Plasticity means remember your plastic. Okay. Now the elastic limit. Okay, so elastic limit is the greatest stress that can be applied to it without causing plastic or permanent deformation. So all the materials have some elastic limit, and after the elastic limit the material will become a plastic limit. So it will behave like a plastic material. Okay, so elastic limit means it is the maximum limit. Before that the material will behave like a elastic. So here this is called as stress strain curve. So you just remember the elastic limit. Don't focus on the stress strain curve. So anyway we are going to see the stress strain curve in detail in the upcoming lectures. Okay. So just a load is applied. You can see the animation here. So I am applying a force. So its stress increases, and after this point it will behave like a plastic material. So before this the material will behave like an elastic, which means up to this load, if you remove the load, up to this point if you remove the load, then the material will come to its original shape. So that is the maximum limit. You can see that. So it is the greatest stress that can be applied to it without causing permanent deformation. So up to elastic limit the material will come to its original shape after the load is applied. So that is elastic limit. Now this law is very important to find the relation between stress and strain. So Hooke's law. Hooke's law states that when the material is loaded within elastic limits, so up to this point, so within elastic limit, the stress is proportional to the strain produced. So this law is very very important. Within elastic limit, remember that Hooke's law will work up to the elastic point. So within elastic limit, the stress is proportional to strain. Okay, so sigma is stress and E is strain. So now to remove this constant, what I am going to do is I am going to add to remove this proportional. I am going to use a constant, that is sigma is equal to E into E. Okay, so here sigma is the stress, E is the strain, and E is the constant that I have used. So now is Young's modulus. So in the previous equation I have used sigma is equal to E into E, and further capital E is equal to sigma divided by E. So this E is called as Young's modulus or modulus of rigidity. So it is the ratio between tensile stress to tensile strain, or compressive stress to compressive strain. So E is equal to stress by strain, that is sigma by E. So the unit for E is Newton per mm square, because the strain doesn't have any units. So this is Young's modulus or modulus of rigidity. It is applicable for tensile or compressive stress. Then the next one is modulus of rigidity. So in case of shear stress, then G is used. So G is the ratio between shear stress to shear strain. So here tau is shear stress and gamma is shear strain. Okay, so it is the ratio between shear stress to shear strain. Okay, now finally the factor of safety. So we have seen the different kind of stresses and plasticity, elasticity. So finally we have seen the relation between stress and strain. Okay, so now what is factor of safety? So factor of safety is a beautiful thing in the design concept. It is actually the ratio between ultimate stress to allowable stress. So I'll tell you the factor of safety with an example. So our two-wheeler, our bike is designed to carry a load of 2 persons. So for example, you can put 2 into 100 kgs, that is 200 kg. So the bike is, if assume that the bike is designed for 200 kg. So but in some of the bikes we are going as 3, sometimes it is 4. Okay, so in that case your weight will be 300 kg or 400 kg. So if I design the bike by considering only the 200 kg, then at 400 kg what will happen is the material will fail. So what people generally do is they will consider a factor of safety. They will multiply the load with a factor of safety of 5 or 4 to 5. Okay, so it is into 5 means I am going to design for 1000 kg. Okay, so anyway it is designed to carry for 2, but I have multiplied a factor of safety of 5, so I can carry up to 1000 kg. So your lift, the lift is designed to carry 10 persons, but the lift is designed with a factor of safety of 5. So 10 into 5, it will withstand up to 50 persons weight. Okay, that is the factor of safety. So ultimate stress means the stress at which the material will break. So for example, if the ultimate stress is 500, and if I consider a factor of safety of 3 or 5, then the allowable stress will be 100. Okay, so you just divide the ultimate stress by the factor of safety to get the allowable stress, and after, while designing the component, you have to consider the allowable stress alone. So this is called as factor of safety. It is the ratio between ultimate stress to the allowable stress. Okay, so in this lecture we have seen the different types of stresses, that is tensile stress, I mean starting from what is stress, what is strain, then we have seen tensile stress, compressive stress, then shear stress, then what is meant by elasticity, what is meant by plasticity, and the ratio between, the relation between elasticity and stress and strain. So finally Hooke's law and the factor of safety. Okay, so from next lecture we will start doing problems on simple stresses.